Good afternoon. My name's Richard Daniels, and this is the Space's virtual conference on the theme of Net Zero Carbon Climate Emergency 2021. I'm the chair for this webinar. Before commencing with the introduction of our speaker, I'd like to thank our 5 sponsors: Atkins, Faithful and Gould, IES, NPS Group, and Wilmot Dixon for their support. All the webinars over the 2-week period are being recorded and will be loaded to the Spaces YouTube channel. Delegates and Spaces members will be sent a link at the end of the conference. The recordings are only available to delegates and Spaces members. If you have any questions, please include them in the chat box and we'll try and answer them towards the end. This afternoon's webinar is on the Leicester City Council PM 2.5 study using portable air quality monitors and a near real-time dispersion model. It will be presented by Dr. Jolanta Obszynska. The presentation will showcase the delivery of this successful project along with the outcomes and the lessons learned. Jolanta is a Transport Strategy Officer on Air Quality at Leicester City Council, responsible for the Air Quality Management Area in Leicester, Air Quality Monitoring in Leicester, and modelling of air pollutants. She is involved in policy work and various transport projects aiming to improve air quality in Leicester. She received her PhD at the MRC Toxicology Unit at the University of Leicester. Jolanta has got a wealth of experience working on various projects both at local, national and European level. She's secretary to the Leicestershire and Rutland Air Quality Forum. She's a member of the Committee for Investigation of Air Pollution Standing Conference and a member of Defra Local Authorities Advisory Group, as well as a member of the East Midlands Air Quality Network for Public Health England. Jolanta, welcome and thank you for supporting the Spaces 2021 conference, and over to you.
Thank you very much, Richard, for a marvellous introduction. I'm very grateful to be here and to be able to present our projects, which we are really proud of. And as Richard said, today I'm going to talk about the air quality project in PM 2.5 study that we've done in Leicester over the past year and a half. I would like to introduce you to Leicester. Leicester is a city located in East Midlands, and it's unitary authority, and with a population of over 350,000 people. It's famous for discovering a king under the tarmac, for its football achievement in recent years, and I'm hoping soon it will be very famous for the way we approach and tackle air pollution. Let me talk a little bit about the legislation we currently have in England for the air quality objectives. We've got Environment Act 1995, which requires local authorities to undertake detailed review and assessment of air quality. In Leicester, we've done ours in the year 2000. We identified breaches of statutory objectives, and we found that we are exceeding annual levels for NO2. We don't breach any other objectives. The legislation requires us to declare air quality management area. In the year 2000, we declared air quality management area for Leicester based on an exceedance of NO2. We extended it in 2008 by 150 houses. The legislation requires local authority to produce air quality action plan, which tackles their exceedances, and also to produce annual status report, which reports on progress that we make as authority in addressing the air quality issues. The air quality objectives that I mentioned are for 3 species, mainly for NO2, PM10 and PM2.5. There's only one authority in England, which is contained in Loughborough that monitors SO2 levels, and we've got air quality objectives for annual 24-hour hourly means. So for NO2, we've got our objective for annual mean of 40 micrograms per meter cube. For PM10 particulate matter, we've got annual objectives of 40 micrograms per meter cubed. For NO2, we also have hourly means, which are 200 micrograms per meter cube, and we are allowed to reach this level 18 times per annum if we record this level over 18 times. That means we are breaching this objective. For PM10, we don't have hourly, we have 24-hour mean, and very similar to NO2, we are allowed to to monitor, to achieve, well, to record it 35 times, but if it's any more, then we are in breach. For PM 2.5, we have annual mean objectives of 25 micrograms per meter cube. This is a map of air quality management Leicester in area, air quality management area in Leicester. It contains the city centre, inner ring road, parts of our outer ring road, and the radials. In Leicester, the main source of pollution for NO2 is transport, and that's why the AQMA is based on NO2. And also on this map, you can see where our air quality monitoring stations are. We are quite fortunate as an authority, and we do have a robust network of monitoring stations. They are located on inner ring road, on some of the radials, and on outer ring road. We also have 2 AURN stations, so it's urban and rural network stations run by Defra. So as a city, we do have, in that respect, a robust network of air quality stations. So we've got most of those stations are located on roadsides. We know a lot about NO2 PM10 levels in Leicester, and before this project we were concentrating our efforts on gathering as much information, as much data on NO2. Our network has been active for over 20 years, so we have a wealth of information on NO2 and PM10, but very little on PM 2.5. What you can see on this slide is one of our air quality stations. This one is a roadside location at Abbey Lane. You can see the NOx analyzer there and old TIOM analyzer. We've upgraded our particulate matter analyzers to BAMs, and as I mentioned before, we also have 2 AURN stations. So the stations and the data that we've currently, well, that we had before this project was geared towards NO2 and PM10, and we had no PM 2.5 analyzers or monitors. As I mentioned already, it is a requirement and a statutory duty to produce a quality action plan. This is the cover of our air quality action plan, and you've got a link. If you're interested, you can go onto the website and have a look. And our air quality action plan has got 4 main themes, concentrating on planning, traffic, environment, policy. Within those themes, we've got 16 actions. The actions concentrate on various areas of interventions, improving the bus fleet, improving the junctions, improving the network, management of the traffic, improving walking, cycling facilities in Leicester, working with other departments, working with central government as well. I'm not going to go into the detail of our equality action plan, but it's very robust, and you've got the link in a previous slide that you can use and have a look. As well as the equality management area to address NO2 and PM10 levels, we also declared a small control area. Firstly, it was designated in mid-70s, and just to make residents and businesses aware that it exists, we issued a single small control order on June 2018. As a result of this, now residents and businesses are not allowed to use unauthorized fuels. They only are allowed to burn authorized fuels, and we do provide the information for this. And the fine is up to £1,000 if you break the rules. The most prevalent question that we get asked is, are you allowed to have garden bonfires in a small control areas? Yes, the simple answer is yes, but you need to follow certain rules. For example, burning green branches producing a lot of smoke and making it a nuisance for your neighbours, it's definitely not allowed. Burning treated woods such as fences in it that sometimes happen. You have to be careful, and you have to check with your local authority what you're allowed to do. I would like to talk a little bit about PM 2.5, what it is, where it's from, what it does. So the PM 2.5 that our project is focused on is a very tiny structure. It's less than 2.5 micrometers. It could be solid or it could be liquid, and it's suspended in the air. The picture on the right of the slide shows a human hair, some sand particles, and on the human hair, the blue beads, they are PM10 that I mentioned before, and then on top of those, you can see the PM 2.5, so you can appreciate how tiny these structures are. I call them structures because the PM 2.5 is often a mixture of organic and inorganic components, and it could be formed from dust, pollen, soot, smoke, and liquid droplets. It's very important to be aware of the fact that you do have man-made sources of PM 2.5, as well as natural sources such as pollen that contribute to air pollution. And very often PM 2.5 it forms as a result of combustion. And in this study, we found that wood smoke burning, it's a very big source of PM 2.5, those particles. Here I've got a very good slide that talks about sources of PM 2.5 and health effect. So you can see the domestic wool and coal burning contributes almost 40% to overall levels of PM 2.5 that we have. You've got industrial combustion, road transport, and industrial processes as contributors. But if you remember at the beginning, Anna mentioned that in Leicester, 80% of pollution for NO2 comes from road emissions. In here, you can see that road transport contributes only 13%. So it's very important when you do a project and when you look into the sources of PM10 to realize where the sources, where the particulates come from, and what sources and what areas to concentrate on and to address. So those tiny particulates, they can have impacts on lungs and on blood. They are able to travel around human body and can get lodged in organs. So you can have accumulations, and there have been various studies, clinical studies, on the concentrations of PM2.5 in various organs. So who is affected? The effects of PM2.5s, the health effects, can be felt by those who already suffer from lung and heart conditions, elderly and very young. And the literature that is available indicates that they can cause reduction in children's lung development. They can cause low birth weight, and they can cause cancer and dementia, so various health effects. And as you appreciate, with the impact, it's very difficult to sort of to forge a direct link, but it's what the literature indicates. So so serious consequences. So our project that we undertook in Leicester was funded by a quality grant from Defra. We had several aims. We aimed to deliver a higher resolution pollution map, 10 by 10 meter resolution, which you appreciate is very fine. It's very fine resolution, and to have near real-time air quality data. We also wanted to deploy 11 portable air quality monitors around the city. We wanted to position those around 6 locations without our air quality management area. We wanted to mount 2 on the electric vehicles that are part of the Leicester City Council fleet. We wanted to ask 2 volunteer cyclists to ride around with the portable air quality monitors, and we wanted to have 1 outside of the city boundary on one of our busy radials. With the data that we would generate during the project, we wanted to provide behavioural change advice to public and to public information systems, and to encourage people to use alternative models of transport, of alternative fuels. As I already mentioned before, the public contribution to pollution levels is significant. So it would be fantastic if we could have everybody on board and doing their bit to reduce pollution levels, to improve air quality. We wanted to monitor actions within a quality action plan and to assess what impacts they had, and if they needed to adjust, to change the scope, or even we needed to add new ones. And we also wanted to deliver a source apportionment for Leicester as well, just to identify what sources of PM2.5 we have, and to better understand where they are, where they're coming from. So we work with a company on this project. We work with a company called Obszynska and use their portable air quality monitors called Zephyrs. They are very versatile monitors, and they can be mounted on lamp columns, on the buildings, or on the poles, or they can be portable. They can be housed in they can be put into backpacks, and people can walk and drive very easily and monitor air quality. So as I said, they are portable, compact and lightweight, and they monitor ambient air in real time. They provide a very detailed air quality measurements in real time, and they can monitor PMs as well as ozone and NOx, and you can use different cartridges for other species. So the list is quite extensive. They can be powered by mains or by solar panels. On this photograph, you can see the black box, which is a Zephyr, and above it, it's electric box that is housing a cable for the electric supply for the Zephyr. But in Leicester, we also have solar panels. What is really important is to make sure that you've got enough light to power the solar panel, because we've deployed one where it was partially in shade in winter, and in summer you've got enough light to produce electricity, but in winter it was cut off, and it was a big problem. We had to change the location due to the shade, and especially, as I said, in winter. And it can be mounted on buildings, on street lights, and as well as being mobile. I mentioned we mounted two on our electric vehicles, which we were quite proud of. And so this is a map of our air quality monitors, the Zephyrs. So we looked very carefully at our city, and I also consulted our pollution team dealing with small control area to find the best locations for monitoring of PM 2.5. We as a council, we do have a wealth of information on PM10 and NO2 levels and the sources. We've had over 20 years of experience in monitoring and addressing those. And only recently, the PM 2.5 monitoring and all that small molecule came into the sort of our understanding and our sort of objective to work and to reduce the levels. So we decided to locate those in areas where we would presume to have sort of contributions, and areas where those levels of PM 2.5 might be high. So we decided to deploy them in the areas where we would know where wood burners would be located. So it would be towards the west and south of the city. We also wanted to collocate some of the portable air quality monitors with a URN station and one of our automatic air quality stations to monitor how accurate these monitors were, and to see if they followed the pattern of the monitoring that the AURN station recorded, and to see how closely they follow the trends and the peaks and troughs in pollution levels. So we took a long time on deciding of the location of each of the Zephyr. And we wanted to have roaming Zephyrs as well, because we thought that with a static one, it was our best judgment to locate them where we did. But we thought with the roaming ones, we could catch all the pollution that is within the city. But unfortunately, what happened is a lockdown happened. So we've started the project mounting those on the cars, on the vehicles in February, end of February, March, and the lockdown happened end of March. So unfortunately, we've got very little data for the roaming vehicles. And also, because everybody worked from home, we couldn't exercise, we could only go out for specific reasons. So we're not able to have a data from cycling. But we still did get a lot of data for our stationary monitors. With the data that we collected, we were able to come up with the source, to calculate the sources of the source apportionment, the sources of pollution in Leicester. And in this slide, you can see a table on the right with the information gathered for emission sources from the Defra, and then on the left, information from one of the Zethers. And just please bear in mind, please note that there's no background or transboundary sources on these. We were just concentrating on presenting how much of local sources were contributing to overall. And you can clearly see that domestic contribution is the highest. I wasn't sure about initially that the transport would contribute very little, but the data clearly showed that the transport is only 11%, which is a very tiny proportion of the pollution. So this is the very valuable information for us as a council. It shows us that domestic sources, which our wood burners, are the main contributors. So the data analysis that we've done, we wanted to see how much information we are going to be able to get beyond just recording the ambient levels of pollution. We wanted to see added value we could get. And this slide represents it really well, because with a graph you can see that the weather impact on pollution levels, and it's huge. So with southeast winds, prevailing winds, you can see that the pollution levels dramatically increase on this at this location, and they are coming from industrial source. So although they are not in the breach of their annual objective, they can easily identify sources of pollution and sort of directions the pollution is coming from within the city. We also looked at how well these monitors can identify domestic emissions when you compare them to traffic emissions and to the urban background, because as you know, city produces a lot of pollution and it forms the urban background. And with portable air quality monitors, they are sort of plus minus 5 microgram sort of differences between your automatic stationary air quality stations. So we're very interested if it's possible to identify the sort of the changes, differences between the domestics and traffic. And this slide represents really well. We're comparing two data from 2 monitors, and you can see very clearly that domestic emissions can be isolated from the urban background, and they are big contributors to overall pollution levels. We also looked at the use of the portable air quality monitors as a means of assessing the traffic interventions. And you can see with we had a junction remodeling project, and by monitoring it, we've identified a big improvements in air quality and big reduction in pollution levels, and it's very, very clear to see. So we were really, really happy with the results that we were getting from those monitors. I've got a little snapshot here that I prepared yesterday. I thought it would be of interest to you. It's we celebrate bonfire night every year, and as you can see how it's easily identified by this equipment, by those zephyrs, and it's a large peak of the night on the night, and also during weekend when people have celebrations as well. You can see very clearly the impact on bonfires on air quality. So just to reinforce the contribution of general public is big, and the changes that can make can really improve air quality. So as well as monitoring real time, we've carried out modeling. So here are the examples of models. The top one is the static model using a data available from Defra background maps and static information. And as you can see, main sources appear to be roads. There are some sort of point sources in domestic areas with residential areas of the city. But it just shows that depends what set of data you're using for your static maps, it can skew a little bit the information. So at the bottom, you've got near real-time model. This is a fluid dynamic based model. Very, very cutting edge, very accurate, and this model is using our local transport model. Our local data is using the network of air quality monitors, AURN, our air quality monitors from Leicester, and the Zephyrs, and it's more accurate. And although this location is a roadside location, not the location with a sort of prevalence of domestic, but I thought it's a good illustration how informative it is and how well you can see the sources. For our project, we use a platform called Map Air to pull our data, to access our air quality data, to see the historic data, and just to see at the glance what was going on in terms of the pollution levels. And it's very easy platform, easy to use, easy to access the data. You can see straight away if your air quality monitors are working, because sometimes there are malfunctions, there are issues, and also see you can see at the glance if you've got any exceedances at any of the sites. Okay, so conclusions to this project is you can identify, target and manage local air pollution sources with monitoring and modeling. You can build a great understanding of pollution being exported and imported within the city. You can create a central database to hold all of the air quality data, and you can access this easily and manipulate the data by generating graphs. You can lead the change, and you can inform citizens and enable them to make informed decisions. I think it's very important. Enabling, it's a very important point, because people with more knowledge, with more understanding how they can change, they can make huge improvements and improve air quality. So you can also, with the portable air quality monitors and with modeling, you can target intervention, traffic intervention, cycling, walking, green routing. You can assess impact to see if they work. You can introduce greater awareness and understanding of the sources, causes and effects of air pollution. You can obviously reduce air pollution, and you'll have healthier, happier citizens, which is our aim, to improve health. As part of the project, we produced a leaflet with information, so it can be distributed when you have, for example, Air Quality Day. and to give information to citizens. We also produce several reports and leaflets, and the reports for solid fuel modelling. So for other authorities, if they want to run a similar project, and one-page information leaflet and guidance for wood burning. And I'm happy to share those if anybody requires it. So for overall conclusions, we have to remember air quality is not only a local problem, it's national and international issue, and it's of high public interest. The pollution contributors are a complex mix of different sources, and they come from traffic industry, but you have to remember they also come from activities by public, and we need public support to improve pollution, improving air quality levels. Monitoring and modelling of pollution enables the authority to make informed decisions and to plan for the future. And it enables to evaluate local interventions as well. As well as this project, our projects that we are currently working on are Defra, also equality grant-funded project, and it's investigating transboundary PM2.2 levels using computer models. We are starting also on another project, also Defra funded, and it's project looking at local interventions at discrete location and their impact on PM2 levels and behavior change. Thank you very much.
Thanks, Jolanta. That was excellent. Really good overview of air quality. And we have one question from Philip Jordan. Should wood burning be allowed, let alone subsidised, for domestic and office heating?
This is the question that should be posed to Defra. Defra at the moment, the advice they give is to use the seasoned wood. So it's the wood that has been drying for 1 year. So the difference, Professor Monks from Leicester University said, if you are using a wet wood in your wood burner, it's the same as if you had a Euro-3 double-decker on top of your house. So this is how much pollution you're producing through the using of a wrong fuel. So this is a question really to Defra. And it needs to be addressed really carefully. For my understanding is people think that by using renewable fuels to heat their homes, they are improving their environment. And their understanding is very limited of the consequences of using the wrong fuel. So
Thanks, Jolanta. That's really interesting.
A public campaign like they used to. Thank you.
Great. You cracked up a little bit at the end. We heard most of that though. So,
sorry.
It's not your fault. Is there a difference between these wood burning stoves? Are some of them more efficient?
I think well, yes, there is, and Defra gives you a list of approved devices. It's how efficient they are at burning, and so the more efficient the more efficiently you burn the wood, the less emissions it produces, the less pollution it produces.
Okay, thanks. And Fiona's made a comment that it was very noticeable in the first lockdown, the lack of diesel in the air. Do you think this would have affected your results?
I had a look, and PM2.5 is different from other pollutants. So it was very noticeable with NO2. There was a 40% reduction per month in a lockdown, but PM 2.5 is different. And with our second project for transboundary pollution, 90% of our pollution comes from agriculture. So the answer is no. There was no huge difference in PM 2.5 due to the lockdown.
And following up on that, what are the agricultural PM 2.5s, do you think? What causes those? Yeah, what are the sources? Is it fertilizer or modern farming techniques?
Yes, fertilizer, and it's sludge, and it's how they plow the fields as well. So I think Defra has got a set of interventions that they want to introduce, or information to give to reduce agricultural sources. But we as a city, yes, we do get a lot.
Do you think that is a major health contributory effect then, the agricultural PM 2.5s?
This is something for Public Health England
to
decide, to give
really.
us, for them to investigate this.
Because people tend to group all PMs together, don't they? And they say that burning toast is just as bad as something else. So
yes. So in my opinion, central government, Defra and Public Health England, they've got a lot of investigation and a lot of advice to give as well. As I said, for the past 20 years, local authorities, we have a wealth of data on NO2 PM10. PM2 came in as a focus in the past couple of years, since Public Health England used it as one of their indicators. I can't tell you, maybe past 5 years top, the PM 2.5 is so present in papers. So for example, in papers, when you read the pollution levels are bad, the journalists, they don't specify which species they are talking about. So public education is definitely needed to make sure that everybody knows, everybody's on the same page.
Okay, and Fiona made a comment 10 years ago. It was all about biomass boilers, promoting them, and now it seems to be that we're trying to get rid of them all now, or limit them more.
Yes, definitely. There's more understanding about the impact of biomass boilers, definitely on air pollution. So you can still introduce biomass boilers, but you have to know which area to introduce them, what chimneys to use, because dispersion is the key to air pollution. So you can have a lot of sources of pollution, but if you've got strong winds, it's all dispersed.
You know about the energy from waste programs, and people burning, a lot of local authorities now are burning a lot of waste for private finance. Does that produce PMs? And I suppose they shoot it right up into the atmosphere, but
well,
do they come down again?
So this is the question for the Environment Agency, because they regulate those. So I would say you cannot introduce just a sort of a burner willy-nilly. You do have to have a sort of analysis of the impact. So you would need filters. You would need, the chimney needs to be a certain height to prevent the fallout of the pollutants. So you
maybe
need to
that's
check
the answer. We could scrub these things out. We can still have biomass boilers as long as we scrub the flue duct.
Probably, yes, probably. But I said, we local authority, we don't regulate those. It's something that Environment Agency has got under their wing. So
central government should be doing it. Yeah. Well, thank you very much. I think we'll draw it to an end because time's moving on.
Okay, thank you very much.
Thank you very much. So I need to thank those for attending the seminar, and I'd also like to take the opportunity again to thank our presenter Jolanta Obszynska and our sponsors Atkins, Faithful & Gould, IES, NPS Group and Wilmot Dixon for their support. I think this video will be recorded and be available for others to see, which would be great. Can you please, there will be a voting thing on to vote on the presentation, how you found it, so it'd be great if people could vote on that. And can I remind you that all the webinars over the next 2 weeks are recorded and loaded onto the Spaces YouTube channel. Delegates and Spaces members will be sent a link at the end of the conference, and these recordings are only available to delegates and Spaces members. So thanks so very much for that, and thanks once again, Jolanta. Great presentation.
Thank you very much. Thank
Bye.
you. Bye-bye.